Right now, there are more foreign bacterial cells living inside your gut than there are human cells in your entire body.
Yeah, it's a wild statistic.
And they might literally be deciding what kind of mood you are in today. I mean, just think about that for a second. We tend to view our digestive system as, well, basically just plumbing.
Right, like a passive tube.
Exactly. You put food in one end, your body, takes what it needs and gets rid of the rest. But what if this system isn't just a pipe? What if it's a chemical, neurological, and microbial ecosystem that actively dictates your immune system, your mental health, and your metabolism?
It completely reframes how we think about being human. I mean,
Yeah.
we are talking about an intricate biological machine that operates with a staggering degree of autonomy.
Yeah.
It doesn't even need your brain's permission to do its job.
Which is exactly why we're doing this deep dive today.
Uh-huh.
Our mission is to track a single bite of food on its complete journey from your mouth to elimination.
It's quite a trip.
It really is.
Yeah.
And to do this, we are pulling from a massive stack of sources. So we've got, foundational anatomy and physiology texts, some genuinely wild historical case studies, and of course the latest modern physiological research.
And it's a journey that takes us through multiple specialized environments. Each one has its own distinct chemical properties and mechanical functions designed to do one thing, really, which is turn the outside world into you.
Okay, let's unpack this, because right off the bat, our sources point out a huge anatomical distinction that people get wrong all the time.
Oh, absolutely.
When we talk about the digestive system, there are really two separate components. First, you have the gastrointestinal tract, or the GI tract. That is the actual 30-foot continuous tube running from your mouth down to the pharynx, esophagus, stomach, small intestine, large intestine, rectum, and finally the anus.
Right, that is the alimentary canal. It's essentially one long hallway running straight through your body.
But then you have all these other famous organs, right? Your teeth, your tongue, the salivary glands, liver, gallbladder, pancreas.
Yeah, the accessory organs.
Right. They aren't actually part of the tube itself. They sit on the outside. They either physically crush the food before it enters, or they act like chemical factories.
Just sort of dumping their secretions into the tube as the food passes by.
Exactly.
Which is a crucial distinction. And if we look at how physiologists formally define digestion, it goes way beyond just, eating and pooping.
Right.
It's fundamentally about breaking down ingested food into molecules small enough to cross into your bloodstream. They break this down into 4 primary linked processes.
Okay, what are they?
So you have ingestion, digestion, which includes both the mechanical smashing and chemical dissolving absorption, and defecation.
Plus motility and secretion, right?
Yes, exactly.
Because without the muscular movement pushing things along and all those chemical juices breaking things down, the whole system just stalls out.
Precisely. And what's fascinating here is how radically our basic definition of this system has evolved.
Totally.
For over a century, science viewed the gut as just a simple chemical vat. Acid dissolves food, and that's the end of the story. But today, we know it is a highly tuned endocrine marvel, releasing its own hormones and a literal neurological powerhouse.
Let's actually talk about that history, because it's crazy. For over 1,000 years, the dominant medical theory came from the ancient Roman physician Galen.
Right, Galen.
He believed digestion was a process called coction. Basically, he thought your body was internally cooking or fermenting the food using innate bodily heat.
Like a literal oven.
Yeah, like your stomach was just a slow cooker.
And it took until the 20th century to truly upend that slow cooker model. We discovered that the gut is actually an endocrine organ.
Meaning it secretes its own hormones.
Exactly. It releases hormones to coordinate the entire digestive process. But the realization that truly turned biology on its head was the discovery of the enteric nervous system.
That's the second brain.
The second brain, yeah. Embedded in the walls of your GI tract, a dense mesh of somewhere between 200 and 600 million neurons.
That is just wow.
To put that in perspective, that is more neurons than you have in your entire spinal cord.
Wait, so when you say a second brain, what are those millions of neurons actually thinking about down there? Like, what are they doing?
Well, they are constantly sensing the chemical composition of the food you just ate.
Yeah.
They detect how much the stomach and intestinal walls are stretching.
Oh, I see.
They regulate local blood flow to maximize absorption, and they coordinate all the complex muscular contractions to keep things moving.
And this runs completely on its own.
Completely. This system is so robust that if you were to surgically sever the physical connection between the gut and the brain in your head, the gut would just keep doing its job. It really doesn't need central command.
And as if a second brain wasn't enough, we now have to factor in the gut microbiome.
Oh, the roommates.
Yeah, the roommates. We are talking about roughly 38 trillion bacterial cells living mostly in your large intestine. And they aren't just freeloading down there.
Not at all.
They actively participate by digesting complex fibers we can't break down, synthesizing essential vitamins like K and B12, and even training our immune cells on what to attack and what to ignore.
They are an active, vital organ in their own right. We've moved from seeing the gut as an isolated tube of acid to recognizing it as an incredibly diverse, symbiotic ecosystem.
So for 1,000 years, we thought the gut was essentially a biological slow cooker. But really, it's more like a modern smart home system.
I like that analogy.
Right. It has its own localized Wi-Fi network of neurons sensing everything, its own automated chemical dispensers, and 38 trillion tiny roommates actively helping pay the rent.
That is a remarkably accurate way to picture it. The sheer coordination required to make all those interconnected systems work seamlessly is staggering.
But if the system is so automated and buried so deep inside us, how did we even figure out it wasn't just a slow cooker? I mean, you can't exactly look inside a living stomach to watch it work.
Well, we couldn't. Until a very specific and frankly gruesome accident occurred in 1822.
Right. Alexis St. Martin, a young French-Canadian fur trapper who gets accidentally shot in the abdomen at close range with a musket. An army surgeon named William Beaumont treats him.
And he survives, miraculously.
Miraculously. But his wound heals improperly, leaving a permanent open fistula. Literally, a hole leading directly from the outside of his abdomen into his living stomach.
And Beaumont immediately recognizes the scientific opportunity here. He suddenly has a living, breathing window into human digestion.
Which is pretty dark when you think about it.
It is. Over the next decade, Beaumont essentially uses St. Martin as a human test subject.
It's wild to read about. He would tie pieces of food to strings, lower them into St. Martin's stomach through the hole, and then pull them out hours later to observe how fast they dissolved.
Yeah, he extracted gastric juice directly to run chemical tests on it, too.
And in 1833, he publishes his findings, proving definitively that digestion is an acidic chemical process, not just mechanical churning or internal cooking.
It was a monumental scientific breakthrough. I mean, it proved the presence of hydrochloric acid and the enzyme pepsin.
Wait, so the foundational text of human digestion is basically the result of an ethical nightmare.
Pretty much.
We only know how stomach acid works because a poor, uneducated laborer couldn't say no to his doctor. Because the sources explicitly state St. Martin was unwilling, resentful, and even tried to run away multiple times.
This raises an important question, and it's actually why this case is a staple in modern bioethics courses.
I bet.
Medical consensus was formed here at a massive human cost. St. Martin was Beaumont's employee. There was a huge power imbalance and absolutely no informed consent by today's standards.
Right.
It's a dark reality of early empirical science.
It's chilling. But the empirical discoveries kept coming, right? Later in the 19th century, Claude Bernard proved that pancreatic and intestinal secretions are what actually digest fats.
Yes.
And then there's Ivan Pavlov. Most people hear that name and immediately think of the salivating dogs and classical conditioning and psychology.
The famous bell ringing.
Exactly.
But Pavlov didn't win his 1904 Nobel Prize for Psychology. He won it for the physiology of digestion. Wow, really? Yeah, he mapped out how the nervous system regulates gastric and pancreatic secretions. The whole salivating dog phenomenon was originally just a side effect he noticed while trying to measure digestive reflexes.
That is so interesting. And we absolutely have to mention William Bayliss and Ernest Darling in 1902.
Oh, crucial figures.
They were the ones who showed that when acid hits the small intestine, it triggers a chemical messenger. That messenger travels through the blood to tell the pancreas to release neutralizing fluid.
And that messenger was secretin, which happens to be the very first hormone ever identified in the human body.
Which is huge.
Their work on the gut literally founded the entire field of endocrinology.
Okay, so armed with the knowledge that this is a highly coordinated chemical and hormonal process, let's actually follow a bite of food into the tube and see this smart home system in action.
Well, the process actually begins before you even swallow.
Right, in the mouth and pharynx. Your teeth do the mechanical shredding mastication. But at the same time, your accessory organs, the salivary glands, are pumping out roughly 1 to 1.5 liters of saliva every single day.
Which sounds like a lot.
It does. And that saliva contains an enzyme called salivary amylase, which immediately starts breaking down complex starches into simpler sugars, which explains why if you take a piece of plain bread and just chew it slowly for a minute without swallowing, it actually starts to taste faintly sweet.
Exactly. The chemical digestion is happening right there on your tongue.
So what happens next?
Once you do swallow, the food enters the esophagus, a muscular tube about 25 centimeters long. Now, a crucial point here, the esophagus does no digestion. Its sole purpose is transport.
And this is where a lot of people have a major misconception.
Oh.
Yeah, people think swallowing is like dropping a coin down a water slide. Like you let go and gravity just pulls it down to your stomach.
Right, right.
But because of a process called peristalsis, the esophagus is actually a conveyor belt. These coordinated ways of muscle contraction actively crush and push the food downward. You could swallow a bite of food while hanging upside down in zero gravity, and it would still reach your stomach.
It is an entirely mechanical, incredibly powerful wave, which eventually delivers the food into the stomach, a highly expandable muscular sac.
Highly expandable is an understatement.
True. When empty, it's about the size of a large shot glass, holding maybe 50 milliliters. But after a large meal, it relaxes and expands to hold 1.5 liters or more.
And this is where the famous acid vat comes in.
Yes, the stomach lining secretes hydrochloric acid at a pH between 1.5 and 3.5.
Which is insane. That is roughly 1,000,000 times more acidic than your blood. Our sources say it's acidic enough to dissolve a razor blade over time.
It is. But the primary role of that acid is frequently misunderstood. Well, yes, it helps break things down, and it activates an enzyme called pepsin, which begins the complicated process of dismantling proteins. But even more importantly, the acid acts as a massive security checkpoint.
Like TSA for your body.
Exactly. Its primary function is antimicrobial. It is there to kill the vast majority of bacteria and pathogens you swallow before they can colonize the rest of your delicate GI tract.
Which naturally begs the question, if it can dissolve a razor blade and kill bacteria, why doesn't the stomach digest itself?
A very thick, highly engineered mucus bicarbonate layer coats the entire inner wall of the stomach.
Ah, built-in armor.
Exactly. It physically blocks the acid from touching the stomach cells, while the bicarbonate neutralizes the acid right at the surface. When the stomach is done churning, what leaves is no longer food. It is a highly acidic, semi-liquid slurry called chyme.
You know, I feel completely lied to by my old biology classes.
Why is that?
Well, if the stomach just turns food into a slurry called chyme, why have we spent our whole lives obsessing over stomach acid? What is the stomach actually doing if it isn't extracting the nutrients?
It's essentially a prep kitchen and a decontamination chamber. The stomach gets the credit because its location and reactions are more visceral to us. We feel full there, we feel nausea there, we feel heartburn there.
That makes sense.
But the real star of the show, where the actual mission of the digestive system is accomplished, is the small intestine.
Okay, let's get into the main event then. Despite its name, the small intestine is the longest section of the tract, measuring about 6 meters or 20 feet in length.
It's massive.
It is, and it's divided into 3 sections, the duodenum, the jejunum, and the ileum.
The duodenum is where the real chemical magic happens. When that acidic chyme enters, it triggers the pancreas and the gallbladder to dump in a flood of enzymes and bile.
Just bombarding it.
Exactly. They immediately neutralize that dangerous stomach acid and start aggressively tearing apart the fats, proteins, and carbohydrates into their basic building blocks.
But the sheer scale of the absorption is what blows my mind.
The surface area.
Yes. The inner wall of the small intestine isn't smooth. It is covered in millions of tiny finger-like projections called villi, and those are covered in even smaller microvilli.
The brush border.
Right, creating this brush border that maximizes the surface area. Our sources estimate the absorptive surface area of your small intestine is between 30 and 40 square meters.
Which is hard to even visualize.
You essentially have the surface area of an entire badminton court crammed into your abdomen, all designed to grab hold of passing nutrients.
And it needs that vast surface area to efficiently pull every possible usable molecule out of the chyme and into your bloodstream. But it doesn't just toss those nutrients randomly into circulation.
Oh, no, it has a whole screening process.
Right. The small intestine has a dedicated superhighway, the hepatic portal vein. This vein ships all those newly absorbed nutrients directly to your liver for a massive toxicity screening and metabolic processing before they are allowed into your general blood supply.
Okay, but what about fats? Our sources emphasize that dietary fats take a completely different route.
They do, because fats are hydrophobic, they don't mix with water or blood.
Right, oil and water.
Exactly. If you just dump them into the bloodstream, they would clump together and clog everything up. So the bile from your gallbladder emulsifies them first, acting like dish soap on a greasy pan.
Oh, that's a great visual.
Then, instead of entering the bloodstream directly, the fats are packaged and absorbed into specialized lymphatic vessels called lacteals.
Lacteals.
Yes, think of the lacteals as a dedicated freight network, safely transporting the heavy cargo of fats through the lymphatic system before slowly releasing them into the blood near your heart.
The small intestine really is the critical supply chain for your entire metabolism. And if we want to talk about how powerful this process is, think about a food coma. When you feel exhausted after a huge Thanksgiving meal, that isn't just you being sleepy. That is your enteric nervous system actively hijacking your blood supply, routing it away from your skeletal muscles and brain, and pumping it into your GI tract to power this massive badminton court-sized chemical plant.
It demands an incredible amount of energy to operate.
Okay, so after the badminton court extracts all the usable nutrients, what's left moves into the large intestine, or the colon. This is about 1.5 meters long, and its main job is reabsorbing water and electrolytes from the waste.
And this is where our 38 trillion bacterial roommates live.
Right, the microbiome goes to work on whatever's left.
Yes. They ferment the indigestible fiber that made it through the small intestine, and in doing so, they produce short-chain fatty acids that your body can actually absorb and use for energy, along with synthesizing those crucial vitamins we mentioned earlier.
Finally, the dehydrated waste reaches the rectum and the anus for storage and elimination. And this is governed by an internal sphincter, which is involuntary, and an external sphincter, which is voluntary.
So it's the exact moment where your conscious control finally takes over again.
From the moment you swallowed to the moment of defecation, the entire process was run autonomously by that localized second brain and a cascade of hormonal triggers.
It really is an autonomous marvel.
So now that we've mapped the entire tube, let's talk about where things go wrong. Because misunderstanding this system has led to some massive medical failures, and understanding it properly is driving today's biggest health breakthroughs.
Oh, that's very true.
Let's clear up some quick misconceptions first. We mentioned the gallbladder dumping bile into the small intestine, but the gallbladder doesn't actually make bile.
No, it does not. Your liver produces bile continuously. The gallbladder is merely a storage pouch that concentrates the bile and squirts it out on demand when you eat a fatty meal.
So if you have it removed.
If you have your gallbladder removed, your liver just keeps making bile. It just drips continuously into the intestine instead of arriving in one big dose.
Good to know. And for everyone who was terrified as a kid, swallowing gum does not take 7 years to digest.
Thankfully, no.
Gum is mostly indigestible, sure, but it moves through the GI tract at the exact same rate as everything else and passes intact in a few days.
Those are harmless myths, but there have been deeply harmful medical misconceptions. The history of peptic ulcers is a perfect example of dogma-blinding science.
Oh, this story is incredible. For decades, the entire medical establishment blamed ulcers on stress and excess stomach acid.
Just an accepted fact.
Yeah, backed by a massive pharmaceutical market for antacids.
The assumption was that no bacterium could possibly survive the highly acidic environment of the stomach.
Right, the acid vat. But in 1982, two Australian physicians, Barry Marshall and Robin Warren, proposed that a specific bacteria, Helicobacter pylori, was actually burrowing into the stomach's protective mucus layer and causing the ulcers.
And the medical community basically lashed them out of the room.
Literally laughed at them.
They lacked the animal models to prove it, and the stress also dogma was just too entrenched for anyone to listen. So Barry Marshall took matters into his own hands.
He literally drank a petri dish full of cultured H. pylori bacteria. Just chugged it.
Just drank the whole thing.
Within days, he developed severe gastritis, proving on his own body that the bacteria caused the damage. It revolutionized medicine. Instead of lifelong acid suppressants, ulcers could now be cured with a simple course of antibiotics.
And Marshall and Warren won the Nobel Prize in 2005. It is a stunning reminder that even the most well-entrenched medical consensus can be completely wrong when it fails to account for the sheer complexity of the body's ecosystems.
And speaking of complex ecosystems, we have to touch on the modern debate around leaky gut. You see this all over supplement marketing now, people claiming a leaky gut is causing their brain fog, their fatigue, everything.
The science here is very specific, but the marketing often outpaces it.
How so?
Well, increased intestinal permeability is a real, measurable phenomenon. We see it clearly in autoimmune conditions like celiac disease or inflammatory bowel disease, where the tight junctions between the intestinal cells fail and let large molecules slip through. However, leaky gut syndrome as a standalone catch-all diagnosis for generalized symptoms is not currently recognized by mainstream medicine. Much of the marketing around it is simply not backed by the rigorous evidence required for those specific claims.
But the gut's overall influence on the rest of the body is undeniable. When we talk about why this matters today, nearly every major modern chronic disease intersects with this 30-foot tube.
Absolutely.
Obesity, type 2 diabetes, irritable bowel syndrome. We've got gut-associated lymphoid tissue, or GALT, which represents a massive portion of your immune system because the gut is the largest surface area exposed to the outside world.
It's the front line of defense.
And we're just starting to understand the gut-brain axis, how those millions of neurons communicate back and forth with your actual brain, impacting depression and anxiety.
We are also seeing the immediate pharmaceutical application of basic digestive endocrinology.
Oh, like the weight loss drugs.
Exactly. The current explosion of GLP-1 weight loss and diabetes drugs, like semaglutide, are quite literally mimicking a hormone that the gut itself produces naturally after you eat.
Here's where it gets really interesting. We aren't even inventing new mechanics with these blockbuster drugs. It's like we're just hacking the gut's own email system.
That's a great way to frame it. Think of the hormone secretin discovered by Bayliss and Starling as the first biological email ever identified.
Okay.
Today, drugs like Ozempic are synthesizing a very specific gut email called GLP-1 and blasting it to your brain's inbox. They are tricking your brain into thinking you just ate a huge meal and that your GI tract is full, even if your stomach is completely empty.
We're just hitting reply all on the evolutionary engineering that already exists.
That's exactly what we're doing.
So what does this all mean? When you step back and look at the big picture, this isn't just plumbing. The digestive system is a 30-foot, acidic, hormone-secreting, bacteria-housing second brain, and how it functions dictates so much of our modern health landscape.
I hope you remember that every single time you sit down to eat a meal, you aren't just filling a gas tank. You are feeding an entire symbiotic ecosystem. You are triggering a cascade of automated nervous system reflexes that rival the complexity of your spinal cord.
It really makes you rethink who is actually in the driver's seat.
Yeah.
Which leaves me with one final thought for you to chew on. If your enteric nervous system can operate completely independently of your brain,
Yeah.
and if your large intestine houses 38 trillion bacterial cells that literally outnumber your own human cells' bacteria that actively manipulate your immune system and synthesize the chemicals that affect your mood.
It's a lot to process.
It is. Who is actually in charge of your body? Are you making the decisions, or are you just a highly advanced walking life support system for a microscopic alien colony living inside a 30-foot tube?